So welcome to Up Close and Personal with NFC and Android Beam. This is Martijn and I'm Robert. We both work on the NFC and Beam team on Android. And we're going to tell you about NFC and Beam. Everyone is in the right session, yeah? This is a good time to leave if you don't want to get really excited about NFC. Cool. Martijn, take it away.
Let's get started. All right, so a show of hands. How many of you guys actually know what NFC is? Wow, that's almost all of you. Just for the few of you who don't, we're actually going to go through a few slides to explain what exactly the technology is and what it does, what's so great about it. So NFC stands for Near Field Communication. And basically, it's a wireless technology, very much like Bluetooth or Wi-Fi. However, there are a few key differences to NFC from these technologies. So one of the main differences is that NFC is very short range. So it just works up a distance of a few centimeters instead of the meters that you're used to from Wi-Fi or Bluetooth. We actually think short range is a great feature of NFC, and we'll show you more in a moment. Another difference between NFC and the other wireless technologies is that it has a fairly low data rate. So the typical data rates for NFC are a few hundred kilobits per second, not more. So you don't want to be sending too much data over NFC at a time. A few kilobytes is a good maximum. And the final thing about NFC that's different from the other wireless technologies is that it's really no setup at all, right? So you know with Bluetooth, when you want to do something, you always have to enter a pin, you have to do pairing. It's really annoying to get stuff set up. The great thing with NFC is that when you bring devices into range, immediately they set up a connection and they can start talking to each other. So you don't need to do any pairing, no pin setup, it just immediately works. So when you have NFC on your device, what can you actually do with it? So I think there's two main use cases of NFC. The first one you see on the left, which is what we call passive tags. Now, passive tags are small form factor devices. They come in lots of form factors, but they're typically the size of a credit card, sometimes a bit smaller. They are often stickers, so you can put them onto stuff. And their main function is really to store a small amount of data. The most tags can store up to a few kilobytes of data. So what you can typically put into a tag is a simple set of data, like a URL to a website, a link to a YouTube video, a vCard for a contact that you know about. Now, what makes these tags really special is that they don't require any power, and that is where the passive comes from in the name, right? So you don't need to put any battery in these. Whenever you put an NFC-powered device on top of this tag, the NFC field in your phone will power the tag, power it on, and allow it to read the data from the tag. The other thing about tags is that you can often reprogram them as well, so they're write many times. So you can write them once, and if you decide you want to store something else on it, you can just override it and put whatever you want on it. And the second thing about them is that they're also lockable. So in case you do really want to finalize the data that you have on a tag, you can lock them to make sure that nobody can override your tags, which is great for a lot of use cases. Now, the second way to interact you see on the right. So typically you have like two powered NFC devices. So an example is if you have two phones or a phone and a tablet that both have NFC. When you bring these two devices together, they can immediately start communicating to each other. And the main differences between this and tags is that with tags, you typically store a set of data on it, and it's like a static amount of data. Whereas when you put two active devices together, you can change the data dynamically from the application that you want. And that's one of the main use cases of Android Beam that we'll show you later. Another use case that you probably all have seen here at the conference is Google Wallet, where you put your phone up to a payment reader and you can do payment. So I do really want to go into the 5 centimeters thing because that's something that I really hear a lot. People think this is a limitation of NFC. I think this is the greatest feature of NFC and what makes it really great. So imagine you're in a room full of smart devices. Like you have a room with a Nexus Q and a Nexus 7. And you maybe have a smart TV in there, even a bottle of wine, which has an NFC tag on it. How do you determine which device you're going to interact with? Well, the easy answer is just by touching it, right? So if you want to interact with your Nexus Q, tap your Nexus Q. If you want to interact or get data from the bottle of wine, tap the bottle of wine, and it may show you the manufacturer info about it. So this allows you to be really specific about the way you interact with stuff. So this is one of the main use cases, touching physical objects for digital interaction. And the other use case comes from actually having two active devices. So if you have two phones, you can have a virtual object on one of these phones. Virtual object can be like a URL or a business card. You can just beam it across. And you can be really selective about where you send it to. And this is really great about short range. It allows you to be selective about how you interact with different devices. I'll hand it over to Robert to talk a bit more about different NFC use cases.
Thanks. So what can you do with NFC? Well, we've got a list here on the slide, which I won't read because you can all see it, but these are really just the usual suspects. Whenever you read a report about the future of NFC, all of these use cases come up. But there's going to be lots of new things. Martijn introduced the idea of peer-to-peer, two active NFC devices communicating with each other. And as many new phones come with that capability, we're going to see lots and lots of new NFC use cases. Also, applications which use NFC to share are going to drive this, and it's all going to get much more interesting. We really think of NFC as being very, very simple. It is a very simple technology. It doesn't actually do a whole lot. When you think about it, HTTP doesn't do a whole lot either, but HTTP enabled the web and all of the amazing things you can do with the web. So don't be fooled by the simplicity of NFC. We think that's actually where its raw power comes from. We want to keep it simple. It's a very basic technology, but when you start to use it, then you can start to harness the power and you can really get imaginative, and we really do think the limits of NFC are just the limits of your imagination. The other question people often have is, well, when is NFC going to happen? We think it's already here. Don't wait too long. You really should get started, and it's great to see so many of you here today interested in NFC and wanting to learn more. If you were in the keynote yesterday, does anybody remember what the number was for the number of Android devices activated with NFC every week? No, no one remembers. Thank you. Okay, 1 million. Thank you. Yes, it's 1 million new Android devices every week activated with NFC that have all of these capabilities. And it's moving into low and mid-end, low-range and mid-range devices. It isn't just the high-end phones that have NFC now. So let's take a closer look, because this is going to come now not just in phones and other devices, but in accessories, and we're going to show you that later on. Lots and lots of smart objects. Maybe not quite the bottle of wine that Martijn mentioned earlier. But let's take a closer look at what you can do on Android. Android provides a framework for NFC so that you can create whatever your application and your users need. And as it says on the slide, we support all the common passive tag types. We have APIs. And you can even launch an application using NFC, more of which in a little while. But we think tags are just the start. NFC, as it becomes more widespread, is going to bring magic to this platform. Let's take a look at Android Beam. Android Beam enables magic sharing. It makes it really, really easy for you to give your users a magical experience. It's deliberately very, very simple with almost no UI. There's nothing to it. And again, we'll show you more about that. All you have to do is bring the two devices together with their screens unlocked. That's important. We want users to stay in control here. This is a personal device. The screen has to be unlocked. The phone has to be on for NFC and for Android Beam to work. Whoever wants to share just taps on the screen to confirm that they're happy for the information to be sent. And the context from their application, normally what's shown on the screen, gets beamed across to the other device. It really is that simple. There are no menus. There are no dialog boxes. There's nothing to get in the way. And that's why we have that touch to beam, just to make it very, very easy. So let's take a look at some of this in action with some demos. So we'll switch over so we can see our devices here. So as you said, it's really, really easy to share content. On my phone here, I've got an interesting article which I probably should share with you because it contains some fascinating news. This is from People magazine, one of my favorite websites. And as the Wi-Fi loads, you'll see it's an article, there we go, about Prince William and his $16 million fortune. Not sure about his dress sense, but we'll leave that aside. No wonder Kate's laughing in the background. But if I wanted to read this on my tablet, got a Nexus 7 here, it's very easy. All I would do, put the phone down, touch to beam, and in just a second or two, it's already open on the tablet. And once again, as you know, the Wi-Fi is a little bit slow here, but it's going to bring up the article in People magazine very, very quickly. I can do exactly the same. Come on. You can see the URL's gone across. It works. We're now waiting for Wi-Fi, but that's Beam. It is very, very simple. This doesn't bode well for the YouTube demo if we cannot get a web page to load, but let's give it a shot anyway. So I've got YouTube running on this phone, and I was going to show a video from the Android keynote last year. But let's keep on rolling. What YouTube does is it actually starts the video playing at exactly the same spot on the receiving device. So if you're halfway through a movie or halfway through something, it'll take you there. Very easy for you to skip back to the start if that's what you wanted, rather than fiddling around to try to find the playhead. So again, we're transferring the context of the app from one device to the other. So here's a demo that doesn't rely on Wi-Fi, because we're not stupid. It is the Moscone Center, and Wi-Fi is always tough here. So I've got a great app on my Android device called Paper Camera. which lets me take nice creative photos. So I'm going to grab a picture of you guys looking awesome. Yeah. There we go. And I'm going to change. I'm going to make it look like you're kind of drawn in aqua pastels. So that's how I roll. So I've got my aqua pastel photo. Martijn, oh, you haven't got a paper camera.
No, it looks really cool, though.
It is pretty cool. Let's see what happens when I beam an app from this device to a device that doesn't have the app installed. So I just tap to beam, and when Martijn flips over, you see it's gone to the Play Store. Thank you. So Beam is a distribution mechanism for your apps, and that's automatic. You don't have to write any code. Every Android app will do that when two Beam-compatible phones come together. So what's happening now, once again, relying on the Wi-Fi, which, so we'll move on. A bit like a cookery show. We've got one in the oven we made earlier. So we've now got Paper Camera installed on another device.
Yep, let's try this one.
And I'm going to snap another photo, but Aquatint didn't really work for me, so I'm going to switch to my favorite, which is Andy Pop. Now, Paper Camera is a great app, and it's got lots of settings. So I can grab this photo, which I've now played around with. Let's see what happens when I beam. So Martijn, let's get your Paper Camera. Let's just have a look. I
haven't launched it yet, but it'll launch automatically.
Okay, so there's my settings. I've got Andy Pop running, so I'm going to beam that across. Put my phone the right way up, sorry. And what's going to happen now, because the app is installed, you see Paper Camera has opened in Andy Pop. So the exact context from this device, the settings. So, you know, if Martijn thinks, wow, how did you get that cool effect? We pass the information across. It makes it really, really easy. A lot of games developers are using that to start two-player games. You know, so if I'm at the start of a game on my device and want to play head-to-head against someone else, just tap the phones, start a head-to-head connection. So pretty cool uses of Android Beam for peer-to-peer sharing. Martijn's going to show us now some tag behaviors.
Yeah, so really cool stuff you can do with tags is you can just stick them in all kinds of weird places that you like. A really cool use case if you want to show off something like, for example, you hold a presentation at a cool conference like Google I/O, you want to tell people about it. So what you can do is you can hang posters all around the buildings for your presentation. For example, a poster that looks like this one for a presentation. And what you can put all kinds of data in there. So in this case, I put a data in there that links to the Google I/O application so that whenever somebody taps this tag, it'll actually take you to the Google I/O application and immediately show you the session that we're having right here. It shows you more information, you can interact with it, add it to your agenda.
And again, what would have happened there if you didn't have the app installed?
So if I didn't have the app installed, it would have taken me to Market First to install the application.
Cool.
Awesome. So I'm showing you also the really cool keynote yesterday where they showed off the new Google Plus Events use case. I think it was really cool, and it showed a different kind of events than what you can do with Android Beam. So let's say we're having a beach barbecue that we're organizing. If you go Google Plus Events, you probably know the people you want to invite. But let's say you want to have a surprise party. For example, not sure if you guys saw the movie Project X, but it was like really got out of hand because a lot of people showed up that weren't supposed to show up. Well, let's say you put a poster here for a beach barbecue somewhere in your dorm room or in a building somewhere. People can actually tag this poster with their phone. And what it does is it just brings you to Google Maps to show you the actual location of where the party is going to happen. Now, the Wi-Fi was actually, it's pretty good now. It's showing awesome. Sunset State Beach. So this is where you're going to have the party, right? It shows a pretty good location.
Yeah, so we've got the exact location so we can make sure the skydivers arrive on time.
Yeah, awesome.
The bar has been raised. There's not a party without skydivers, guys.
Yeah. So a really cool final use case about tags that I want to share with you is actually that you can couple tags to do actions on your device. So for example, on your phone or your tablet. For example, you can associate a sticker that you put on your bedstand with, muting the volume or launching a different application. Or you can have a sticker in your office that disconnects to Wi-Fi and does the different kinds of settings. Now, there are a few cool applications in the Android market already that allow you to configure a tag to execute certain operations on your phone. And one of the applications I'm going to show you is NFC Task Launcher, which allows you to do just that. So this application, you can define a new tag. And for each tag, you can define a number of tasks that you want to be executed whenever you touch this tag. So let's say I want to create a task for when I go to Google I/O. I think one of the things I want to do when I get here is, launch a Google I/O application to see which sessions I'm going to go to today. I probably want to mute the volume to make sure that during the sessions I don't interrupt anything. Yeah. So let's add an action. I can add an action to launch an application. And for the application, I'm going to select the Google I/O app. Okay. I can add as many actions as I like. So I can add another action related to the volume. I can say the ringtone volume. I can configure it. In this case, I'll just set it to mute. All right. So now I have 2 actions. I can press finish. And the next thing I have to do is I just need to have an empty tag like this one. I can put it onto my phone, touch the phone, and it writes the data to the tag. So what's going to happen now is that whenever I touch this tag, it's going to execute these actions. So we just need to find a good place for this tag. Why don't we use your badge?
Yeah, sure. So I got my badge, which has one of those old-fashioned QR codes on.
Yeah, it doesn't really work very well. Let's do it like this. So now, whenever you touch this tag with any of your phones, what it's going to do, it's going to launch the Google I/O application, and it's going to set the volume to mute. So you can have all kinds of cool actions associated with each of these tags. You just stick them in all the places that you like.
But that could be a trick, because you programmed that.
Oh, sure. You want to try
Does
it
it
on
only
your
work
device?
on your phone? So, oh, there we go. So I can go in there,
yep.
and is it going to set my volume?
Let's do it with this phone.
Do with that
should
one.
work. It does the same.
Awesome.
Yep.
Yeah. Mute.
Cool.
And all launches the app. Cool. Now, actually, all of the things we've shown you are possible today with Ice Cream Sandwich. But we announced Jelly Bean yesterday, and we got some new exciting NFC features. We've added new features to Jay, which we want to tell you a little bit about today, which we think will be very exciting for users and for accessory manufacturers, all of the people who make accessories to work with phones and devices. One of the great things about all of these devices is, they're wireless, they can connect over Bluetooth, but every time on Bluetooth, you need a pin, you've got to have 1, 2, 3, 4, you've got to have 0, 0, 0, 0, and it's a pain. With NFC, you can just tap to pair. So Martijn's got his headphones on ready, and I've got my phone here, so I've got some music on here. So let's see what happens when I tap my phone up here, and it says it's connecting to the headphones, and the music should start any second, so Martijn's rocking out. But hang on, let's bring him back. And disconnecting. Simple as that. God, tough. Yeah, thank you. Yeah. Tough crowd. Actually, that is a bit of a cheat demo because Martijn is perfectly capable of pretending to dance. So we got these speakers, which are just the same, NFC powered. And, after a busy day at Google I/O, I've been partying, want to come home, keep the party rocking, just take my phone. Right? Really, really easy. And when we've had enough crisscross, easy to get rid of them. So once again, NFC making pairing by Bluetooth. That was creating a Bluetooth connection, completely transparent to the user, taking advantage of that 5 centimeters just so that you can come and tap and make things happen. Really, really easy. So we got rid of those horrible pins that used to slow you down. So let's have a look at another area that could be improved by getting rid of pins. Let's talk about the future of file sharing between devices. So quick question, how many of you have transferred a file between 2 devices using Bluetooth in the last year? So maybe I think it's about a fifth of the hands. In the last month? Yeah, a few hardcore masochists. And in the last week. So kind of no, you've been having way too much fun here to be messing around with Bluetooth file transfer. And if you look at all the steps that it takes to achieve Bluetooth file transfer, it's not really surprising. So let's have a look at the future of sharing. So I'm going to take a quick picture of you. I'll do this side just to be fair. I don't want you feeling left out. So there we go. So I've got a picture of you, which is on my phone now. So let's see what happens.
Switch to Wolf Vision.
Yeah, thank you, Martijn. So, sorry, you need to be able to see what we're doing. So, I've got that picture here, and when I tap to beam it over, let's see what's happening on Martijn's phone now. So, he has a notification that there's an incoming beam. And even though that file is a few hundred K and the phones aren't now within NFC range, you can see it's doing the transfer. So this is much, much easier. So as that completes, it may take a few more seconds because it is quite a big file from a Galaxy Nexus camera.
It's 2 megabytes on the camera.
Yeah, several megs. So how did that happen? Well, the good news is, as you saw there, It's absolutely transparent to the user. There's no steps, there's no confirmation, just the usual Beam behavior. This supports photos and videos. What we're actually doing is initiating, using NFC, the Bluetooth file transfer. So we automatically pair the devices in the background. We don't need the user to confirm because they've used Beam to confirm. And automatically, there we go, it's completed. So Martijn can show that now, just to show we're not cheating. That.
Saying Beam complete. Just have to tap it.
And there's the photo. So how easy was that? And that will work. Thank you. So that's a new public API for you to use, and it can be any payload. These are just the payloads that are built in, so your apps can take advantage of this too. So we've shown you some cool demos. Let's go on to talk about how we think you might want to use NFC in your applications, and we're excited that many of you are already doing that. Here are some reasons why it can be useful to add NFC to your app. Well, users love NFC. It's so easy and natural. You just tap things together and stuff starts to happen. It really feels magical. It's like being in a movie. You know, you can just walk up to things, make stuff happen. It really does give you that kind of Minority Report feeling. The good news is you can make users feel good like that in just a few lines of code. This isn't a big effort for you guys. It's really simple to add it. We're very lucky that we have, you know, so many thousands of great developers like you guys building for Android, but we know it can be hard to make your app stand out. Taking advantage of these new features makes life easy for your users, and it can help your app to do well and to perform and to get users excited. Let's take a quick look at the opportunities. We think there's kind of two ways to look at NFC. When you're doing things with tags, the kind of stuff Martijn showed, you know, putting a poster up, putting a sticker up by the light switch in your home to change your behaviors maybe of your phone, you're probably thinking about new applications and new use cases, things that you didn't necessarily do before. And there's lots of documentation on the web about how to do that. And people think about, you know, games in the real world where you have to go around collecting tags to prove you've been in a place and things like that. If you already have a successful app on Android in the Play Store, what we think you should try to think about is where in that app do your users have something they might want to share? Where might they want to share the context or the content between two devices? Because Beam is a great way to do that. Beam isn't really about new use cases. We were talking to a developer yesterday and he said, well, all it does is share content from one device to another. Well, yeah. We thought that was pretty good, you know. Like, doesn't have to make the tea, you know. It just shares content from one device to another. And that kind of is the point about it. So for the rest of the presentation, we're going to focus on Beam and how to share content and context between devices. And at first, you may not think that your app has anything to share. Maybe you don't take photos or create new content. But just like we showed with Paper Camera, almost every app has some state that might be complex to set up. You know, there's many settings. Think about what's useful to move from one person to another, but also just think about the fact that many people have more than one NFC-enabled device. All of you now have several. You might be looking at something on your phone. You want to look at it on a tablet. You want to make it play on a Nexus Q, for example. It's very, very natural to beam from one device to another. So it isn't always about one person to another. It could just be the same person, you know, who's come into the room or changed context or picked up another device. So before I hand over to Martijn to show you how to make this magic and add it to your applications, I want to point out a couple of pitfalls with Android Beam. We tried to make it really magical, and in a few cases, we've seen some apps that make us a little bit sad because they've somehow managed to break Beam. And when you break Beam, a kitten dies. It really is that simple. So please don't break Beam. Well, how do you break Beam? Usually by adding something to it. And we're not going to name names today because we wouldn't do that because we love all of our developers. But here are some of the things we've seen done. We've seen somebody put Beam on a menu. So over the right-hand side there, you see on the slide, you know, it's like, oh, I want to share now. The user tells your app they want to share using Beam by putting it next to another device. They don't go and choose from a menu. They shouldn't have to do that. That proximity is your cue to share. And when Martijn comes on to talk about the APIs, you'll see how you can even be very late binding and only declare your payload at the time when you're in close proximity with another device. So please don't put it on a menu. Please don't add other dialogues. In the middle there, you've got, you know, a pop-up that we've seen in apps that says, are you sure you want to share? Again, you know, how often do you put your phone within 5 centimeters of someone else's phone? It's a very deliberate act. You do not need to click and say, yes, I'm absolutely sure. So those are all the ways we think you can chase the magic away. So please don't do that. and please just leave Beam be. It's not perfect. We're always going to add new things. We're going to talk at the end about a few ideas about where we might go. But for now, just try and keep it simple. So I don't want to dwell any more on how to do it wrong. I'm going to hand over to Martijn to show you how you can add the magic of beam sharing into your apps.
Cool. So let's take a look at how a beam share works in detail. So let's say you have two devices, device A and device B, and you want to send something across from device A to device B. Now let's say that your application is the one that's running on device A. As you know, Android applications basically consist of a number of activities. What you developers have to decide is, for each activity, does it make sense to share anything over Beam for this activity? And if so, what is that? And once you've determined that, you have to use a few set of simple APIs to tell the Android operating system about the data that you want to share from this activity. So what happens next is that whenever you bring the two devices in range, the Android operating system is going to check which activity is running in the foreground now. Once it has determined that, it'll see that for the application in the foreground, is there anything registered that they wanted to send over Beam? And in case there is, once you touch the button to send, it'll automatically send the payload across. So on the receiving side, you get the data over NFC. And basically, what we do with any incoming NFC data is we try to start an activity to deal with the data. So we somehow have to resolve the NFC data that's incoming to an activity. And we'll go into more detail in each of these steps later. So first, I want to share more about the data format that you use for sharing over NFC. And the data format is called NDEF. So let's first go a bit more into detail about NDEF and how it works. So NDEF stands for the NFC Data Exchange Format. And it's basically a simple message format that was defined by the NFC Forum, which is like the NFC standards organization. And it's backed by all the major industry players. Now, NDEF has really two basic types. One type is the NDEF message, and the other entity type is an NDEF record. Now, an NDEF message is really simple. It's nothing more or less than one or more NDEF records. So it's just an encapsulation of multiple NDEF records. Now, what is an NDEF record? An NDEF record consists basically of a single set of data. So a single NDEF record can be something like a URI, it can be a vCard, it can be a link to a place on Google Maps. You can have multiple of these records in a message. Now, once you go inside a record, let's see what fields it's composed of. Now, the first field in the NDEF record is called the type name format or the TNF field. And all the type name format field does is tell the interpreter how to interpret the second field in the message, the type field. So there are a few distinct values that you can use in the TNF field, and each of those changes the way that the type field is interpreted. You can see some examples on the right. If you use the type name format value of 1, which stands for the well-known type, then for the type, you can actually use a few short byte values. For example, if you specify the type as 55 hex, that means it's a URI. And the reason why this is good is that you only use 2 bytes in the process of specifying which type of record this is. So this is a lot easier than actually spelling out the MIME type in text, right? You remember NFC is low data rate, so you don't want to waste too many bytes. So well-known is really used to have a few well-known record types and be able to encode it in 1 or 2 bytes. Now, a different type name format is, for example, MyMedia. And when you specify type name format as MyMedia, value 2 in the TNF field, that means that the type field will be interpreted as the MIME type of the packet that you're sending. So then in the type field, you can put a string, for example, saying text/plain, which is a MIME type for your record. Next is an optional identifier. Most people actually don't use the identifier. You can put any bytes in there that you want, but the Android operating system doesn't actually do anything with it, so it's purely optional. And the final part is the important part. That's a payload. So in the payload, you put the actual data that you want to share. So in case you want to share, a URI, and the payload would be the actual data of the URI itself. So how do you create such a message with the Android APIs that we have? Well, there's a few ways to do it. The first way is really the hard way. So we have a constructor on the NDEF record in which you can specify all for the fields of the NDEF record. So the first field is the TNF field, in this case well-known. The second one is a URI, type URI. You can specify an ID and get the bytes of it. And finally, you can get the actual payload in it and put the bytes in there. Now, because a lot of people just want to have some standard records like URIs, we actually created some helper methods on the NDEF record class. So instead of using this complex constructor, you can use a lot easier way. Simply call ndefrecord.createURI, and as the only argument, you have to specify the URI that you want, and it will automatically create the record for you. So the second statement is equivalent to the first one. Now, another helper that we have is if you want to create like your own custom MIME type. So ndefrecord.createMIME allows you to specify as a first argument the MIME type of your record, and as a second argument, the payload that you have. So this way, again, you don't need to use a constructor. You just have to pass in these 2 values, and you're done. Now, once you've put in the NDEF records that you want to put in the message, all you have to do is call the endf message constructor, and as an argument, you can specify one or more endf records. In this case, I just created a message with a single record, which is a URI record that I created earlier. So one of the things you might ask when you see these slides is, well, how do I know which type I should use? And I think one of the guidelines is that if you use an existing type, for example, if you were to use text/plain, which indicates text type, then any applications on the receiving device that already have or handle this MIME type will be able to handle this payload as well. So this allows you to reuse applications that can deal with your payload. On the other hand, you may have some very specific payloads, for example, as something that only your app can interpret. In that case, you may want to have like a MIME type that's specific for your application. And in some cases, it's a hybrid. Maybe in some cases, you have an image that you want to share, or even a text file, but you still want a very specific application to handle it. And we don't think you should be going hacking around MIME types in that case. We created a special NF record for that, specifically that use case. And that record is called the Android application record. So what the Android application record does is, if you put it in a message, it'll guarantee delivery of the message to the package that you specify. So you can create an Android application record which specified package com.google.whatever, and whenever this message is received on the other side, the operating system will make sure that that's the package that handles the message. Now you can even put multiple packages, multiple records that represent multiple packages in an NF message. So you can say, well, as a first preference, I want application A to handle this payload, but if it's not available, then please do it by application B. And the other final thing to understand is that even if the application that you specify doesn't even do anything with NFC, doesn't handle NFC intents, it'll still be launched. So it's still, if you create an NF message with an Android application record, it's also an easy way for you to launch an application on a remote device, even if that application does not support NFC at all. And the final thing to know about Android application records is that if the receiving device does not have the application installed at all, it'll take you to the Play Store, where you can actually install the application immediately, which is what we saw before. So just to show you how to build an Android application record, we also have a helper method for that as well. So all you have to do is you create a URI record like we did before, and additionally you create an Android application record by calling create application record. And the only argument you have to give is the package name of the package that you want to handle the payload on the receiving side. And then you simply compose an NF message by specifying these two records. So the first record is a URI record. The second record is the Android application record. And this will make sure that the URI payload goes to the application that you specified. Really easy. So once you've built the NF message, how now do you tell the Android operating system for which activity you want to pass this message? Well, there's two really simple APIs that you can use. So the one that you see on the top is the setNdefPushMessage API. It's a really simple API where you can just pass in any activity, and as a second argument, you can pass in the message, actually the other way around. And what this does basically is tell the Android operating system, for this activity, share this message. And this is really great if you have static content for your activity, like your activity is always sharing the same type of data. So that's when you want to use this API. And there is a different set of use cases where the data that you want your activity to share actually changes dynamically during whatever you're interacting with in the application. So in that case, we actually have a callback variant as well. So what you do instead is you call the setNdefPushMessage callback method. You register a callback with the NFC service. And whenever somebody brings you two NFC devices in range, this callback is called. You can form the NF message that you want to share and return it, and it gets sent across to the other side. So the second use case is really easy for dynamic applications, for example, gallery, where the activity stays the same, but the actual content changes if you swipe your finger across the screen. The important thing to know about the activities that you're passing on is that you're passing into this API is that you can basically call this in any activity state as long as it hasn't been through the onDestroy call. So from whenever the moment you're in onCreate, you can use this API until the moment that it's been through onDestroy, and then it won't work anymore. And even though the APIs allow you to specify multiple activities, we recommend you don't do that simply because for an activity that's not currently running, you don't know if it's already been through onDestroy. So it's the easiest in your applications to just specify one activity. So let's see an actual implementation. I have my activity X from which I want to share an NF message. So in my onCreate, I simply have to get a reference to the NFC adapter by calling getDefaultAdapter. And all I have to do is call the setNdefPushMessage callback API, which I just specified. The first argument is the callback, which is actually also an interface which is implemented by this class. And the second argument is the activity, which is also this in this case. And then you just need to implement the callback. So the callback is called create endf message, and all you need to do in this callback is create the endf message that you want to be shared at this moment. So whenever you bring the devices together, this method will be called. You create the endf message that you want to share, you return it, and then it will be sent across as soon as somebody touches the screen. One thing to note about this callback is that because it is called whenever the NFC link comes up, you don't want to wait too long or block too long in this method. You just want to get the data ready because the user is waiting at that point in time to get to touch and send the data across. So that's all you have to do for the sending side, really. Just specify the data that you want. Tell the Android operating system, for this activity, I want to share this data. So what happens on the receiving side? Well, the receiving side gets an endf message as well in the NFC service. And the NFC service somehow has to translate this message to an activity that can handle it. So how does that work? This slide shows a bit of code that's inside the NFC service. So it's not code that you need to write yourself, but it's just there to illustrate how the NFC service does this. So when it receives the endf message, it takes a look at the first record of the message. And specifically, it takes a look at the type name format and the type fields. And basically, from these two fields, it creates a type that it sets on intent. So the first thing it does is creates a new intent, and the action on that intent is action endf discovered to indicate that it's found a new endf record. And the second thing it does is set the type based on the type name format and the type. And finally, it puts as an extra the entire message in it. So whatever activity is going to handle the message, it can actually get the full message by calling or getting the extra from the intent. And then the NFC service simply calls start activity. The normal Android operating system kicks in to find an activity that actually matches these constraints. So let's take a look at how the type name format and type fields actually are converted into a type field in the intent. So we have a few different records here. The first is a URI record of type well-known. It shows all of the endf fields. So the first is TNF, which is well-known. The second is a type, which is a URI type, the X value that I showed you earlier. And the third is a payload. So this is going to be translated to a data field on the intent, and the data will be a URI http ://www.google.com. Another example is a text data, right? You can also specify text data by using a TNF of well-known. Use RTD text to indicate that it's a text type. You can put some text in a payload. So this is going to be translated to an intent type of text/plain. And there are a few different examples on here. You can also use your custom MIME type. And in this case, your custom MIME type application/vnw.mine will end up on the intent. So there's really a straight mapping from the type name format and the type fields to the type field or the data field that's in the intent. So I told you before also about Android application records. How do they tie into this picture? So basically, the code in the NFC service looks the same for the first part. So you will still look at the first record. You will determine the type from the type name format and the type fields. You'll put the extra, which has the full endf message. But for each application record that you find in the message, you're going to call the set package API on the intent. And basically, this tells the Android operating system to deliver this intent to that package specifically. So for each package that's in there, we first try to start it. If it doesn't work, we try the next one, and so on and so on. And finally, like I said before, if you don't find any activity, you either launch the first application that's in the AER, or if even that is not installed, it takes you to the Play Store to install the application. Now, let's say that you're interested in receiving such an intent. What do you need to do? Well, it's actually really simple. I showed you how the intents are formed, right? It's an action with endf discovered that has a certain type. All you need to do is write an intent filter for your activity that actually will filter for this intent and deal with it. So in this case, let's say I have an activity Y for which I want to receive a specific amount of endf data, a certain amount of endf data. Let's look how it works. Just in the Android manifest for the activity Y, I can specify a few intent filters. So the first one, for example, is an intent filter for the MIME type application/vnw.mine. So the action is the action endf discovered, which is what the NFC service used. The category is default as usual, and you just need to put in the MIME type that you want to filter for. Or the second example is on there as well. If you want to have a URI, for example, google.com/NFC, you can put an intent filter. The action is endf discovered, but the data is the scheme you set HTTP, and you can put in the host and the paths to match exactly what you want. You can also use wildcards in there to match different kinds of patterns. So once you've done it in the manifest, all you need to do is, in your activity that's handling it, in activity Y in this case, you need to get the actual data and do something with it. So in this example, I show you the onCreate method for your activity Y. This will get called by the NFC service. Basically what you do is you just need to get the intent. you need to check the action on the intent to make sure it's an NDEF discovered intent, not a different one. Once you know it's that, you can actually get the payload, the NDEF message from it, by just getting the extra out of the intent. So you can use the intent, get parsable array extra to get the extra out. And then you have the actual message. Once you have the message, you can get the first record, and from the record, you can get the actual payload. So now you actually have the same payload that the other side put into the NDEF record, and you can start processing it or do with it whatever you like. If it's some big data, you probably want to do it on a different thread. So one of the important things about receiving, this is really, really important to understand, is that a design decision we made is that every NFC interaction that you have with your device, be it touching a tag or doing an Android beam, it'll launch the activity in a new task stack. And the reason for it is that we don't really know when you tap a tag, was it really part of the previous activity that you were doing, or is it something new altogether? So this is the default behavior of Android when launching NFC activities. It'll just start a new task stack. Now, for some applications, that may not make sense. It may be that your application always has a single activity, and you want it to be launched always in the same existing task stack. So let's show you how it works. In that case, you can actually specify for this activity that the launch mode is single task. So what this does is this tells the Android operating systems to not create a new task for this specific NFC intent, but instead to deliver it to the existing task that's already running in a separate task stack. And the main difference here is that instead of calling onCreate and giving you a new activity, this will actually call the onNewIntent method, which allows you to deal with the NFC data in the activity while it's already running. Now, there is a final use case that's important. That is if you have multiple NFC interactions with multiple activities. So the previous slide, I just showed you one activity, and you can have multiple NFC interactions with that, and for each interaction, you get a call to onNewIntent. Well, what if you have multiple activities? Well, basically, if multiple activities have the same intent filter, that will pop up the intent or the activity chooser, right? You've seen it before. If you open a URL, you choose between browser and Chrome. This will also happen for NFC interactions. So in this case, what you would typically do is you typically have an entry task where you want to start interacting with your NFC tag, or maybe with Android Beam. And this entry task, you would typically give launch mode single task. So you make sure that it routes to an existing task stack. Now, for all of these subsequent activities, you can use a different launch mode called single top, which means that if that activity is currently running on top, your NFC intent will be delivered to that activity. And you can combine it with a feature we call foreground dispatch. I won't go into too much detail about it here, but foreground dispatch allows you to bypass the activity chooser altogether. You can say to the Android operating system, hey, I want to deal these kinds of intents or intent filters right now, and I don't want any other applications to be able to handle it. All right, so let's talk about some new stuff in J. I'm really excited about this API because it brings together a lot of cool features and technologies. So as we've seen before, it's really hard to get a file from one device into another, right? As you saw by Bluetooth, there is lots of screens and confirmations involved. So let's take a look at how you would do this with the new NFC API in J, which allows you to share pictures and all kinds of large data. So all you have to do is, let's say you have an activity here. And in this activity, I want to share like a URI to a file, or I want to share a URI to a content provider. I can get a reference to these URIs, and all I have to do is call a single method on the NFC adapter calling setBeamPushURIs. And in this API call, I basically specify the URIs that I want to be sent across to the other device. There's also a callback function in this case. And this is really all you need to do. So once you do this, whenever you bring the devices into range and you tap it, Android will actually get the data, send it across to the other side over Bluetooth, which is really fast, and it'll deal with it on the other side and launch an activity to handle it. This is all you need to do. That's quite amazing. I mean, 5 lines of code. It's so hard to get a file onto another device. You just have to write this, and all you get is just instant transfer without any confirmations or whatever. It's just like the gallery demo that we showed you before. So how does it work? It's pretty simple. In the flow that we had before, you have device A and device B. So on device A, you just call this API, the setBeamPushURIs API. And whenever you bring the devices in range, the NFC service is going to transfer the MAC address of the other device, device B, to device A. And this allows device A to set up a background Bluetooth connection, which allows it to transfer the data. So once that's done, the data is actually sent over Bluetooth. The receiving device stores the data in a file then, and it launches an action view intent to actually deal with the data on the remote device. So I want to call this out. This is different from action NDEF discovered. because Action NDEF discovered only works on NDEF data and is specifically to NDEF. However, there are already a lot of applications that deal with the action view intent because it's the main intent that you use for viewing information. So that means that whenever you write some code that does this, if the receiving side already has an application that handles your data, it will automatically be launched, which is really great. So the great thing about this API is that you get all the UI and Bluetooth handling for free, so you don't need to write any Bluetooth code or any confirmations or whatever. You just really need to write these few lines of code to make it happen. And the other thing that's important about it is that you can use it in combination with the NDEF APIs that I showed you before. So the new API will actually only work in devices that have J or later. So this is important, right? You want to have a fallback method in case the device that you're sending your data to doesn't have the new J implementation that allows you to share large data. So what you can do is you can use both APIs. Android will first try to use a new J way of doing things, which is sending stuff over Bluetooth really fast. If it finds out the other device doesn't have Bluetooth or doesn't have the capability, it'll fall back to the URI. So you can still have a fallback mechanism in case things don't work. All right. Let's wrap up. I want to share some things we're thinking about with you guys. So what we hear a lot on the developer forums is that Beam is really only one way, right? You bring the two devices together, and one of the two taps, and then data gets sent across to the other device. In fact, I think if you're really careful with timing and you touch and write at the same time, you can get it going two-way, but that's not really the way to do it. So we're really thinking about supporting two-way communication in Android Beam, and making sure that once you bring the devices together, you can actually ping multiple messages back and forth, and enable much cooler use cases. You can have all kinds of protocols going then. The other thing we hear a lot is customizing the Android Beam animation. So right now you see that whenever you bring the devices together, the screenshot scales down with some nice star field behind it. Maybe we want to give you some APIs to actually specify the screenshot that's shown that's being scaled down. Or maybe you even want to do your own cool custom animations. So that's something we're definitely looking into. And the final thing we want to do is, we have this new great API which allows you to easily send across large files over Bluetooth. And we want to extend it to use Wi-Fi Direct. The main reason we haven't done so now is that this is not a standard yet. So we want to make sure that when we implement it, we want to implement the standard so that it actually works across all of the devices. So we want to make sure you don't have to worry about this. It should just work. And whenever we do implement Wi-Fi Direct, we'll just hide it behind the same API. So to you guys, it'll just be transparent. It'll just work. Something else really important, which I hear a lot, NFC uses a lot of power. You see this in a lot of forums, or people say that it does. So first of all, when your phone is off, or when your phone is locked, the NFC controller is not even enabled. So at that point, it's not really consuming any power at all. Even when your phone is unlocked, and so we enable the NFC controller, still only power is minimal. It's like compared to all the rest, it's like 0.5% of battery usage. So it doesn't really amount to anything. You can safely leave it on. Because if you turn it off, it really breaks the magic, because then you will have to go into the menu settings again, enable NFC to make stuff happen. It's much easier to just leave it on. You really won't notice in your battery usage. Also, NFC controllers in the future will use less power, so I think it's getting better and better. So summarizing what we talked about today, the first thing is really important. NFC is here to stay. A lot of people discuss this also. When are the NFC devices coming out? It's happening right now. We see 1 million NFC devices activated every week, which is like a huge number. There is a lot of growth in that number as well. The second thing we wanted to share with you is that adding NFC to your applications is very easy. You just need to add a few lines of code, and automatically the operating system will take care of the rest, sharing it, sending it across NFC, and dealing with it on the other side. It's so easy, and it really adds value to your application to do stuff like this. And finally, the new J API is really awesome. I mean, you just have to write a few lines of code, and you can automatically send across any file on the file system or any data from a content provider to the other side without having to worry about any pairing or setup, or just bring the devices together, tap, and the file automatically gets sent across. It's awesome. All right, I'm going to hand off to Robert, who's going to talk to you about the Beam viral.
Yeah, so I guess I should add just a quick legal disclaimer. This is not available if you're watching the repeat on YouTube. But for those in the room, who's got the Google I/O app? Most of you, I hope. We actually put a little Easter egg, thank you. Oh, we've already got a winner down there. We put a little Easter egg for you in the app. So if you grab your app and you beam, you will add an item. Sorry, switch. There, you will see an extra new item in your menu, which says Show Android Beam Easter Egg, which looks kind of like that. And if you come up and see us afterwards, we'll give you a limited edition Beam pin. We have just about enough for everyone, but they are only available here today, so do come and grab them. We just wanted to make sure that everyone had tried Beam and everyone had used it, so it was just a bit of fun for today. So sorry, YouTube viewers, come and find me at my desk, and maybe I'll have some pins left. So yeah, that wraps it up. We want to move on to Q&A. So there we go. There's just a reminder so that you can see that. And yeah, let's take any questions about Beam or NFC. And thanks very much for listening. For those of you that don't have questions, there are microphones. It's probably easier if you come and grab a mic, and we'll do what we can to answer. Thank you.
I had a question about the Beam.
Thanks.
Thank you.
Oh, very orderly queue forming. Thank you. Okay, first question.
Do the Bluetooth radios have to be on for the Beam APIs to work?
That's a great question. Actually, we do turn it on for you automatically.
Repeat it to make sure everybody can hear. Sorry.
Yeah. So the question was, does Bluetooth already need to be on for the APIs to work? That's actually not required. So if Bluetooth is off at the moment of the transfer, we automatically enable it for you. When the transfer is done, we turn it off again. So you don't have to worry about turning Bluetooth on before the transfer. It just works.
We take care of it. Next one. Hi.
Is there any way to have Bluetooth as a backup if there's not NFC?
So is there any way to have Bluetooth as a backup if there isn't NFC?
Or use some of the same APIs without having to recode it for a separate Bluetooth?
Not right now. I think in case of that, you would have to use the normal action send APIs to get the data across.
Hi, next one.
Hi. Underlying that, are you using the 2.1 insecure pair, like in the background, or is there some sort of pin happening in the background?
This is implementation of the Bluetooth secure and simple pairing setup. Yep.
Thanks.
Thank you.
The Bluetooth pairing is fantastic. Is it possible to establish a serial style connection, and do you guys provide any example code for that in the new SDK?
Not with the current API. So right now we just allow you to automatically set up OBEX push for file transfer, but it doesn't allow any other sockets yet. But it's something we may look into in the future.
Thank you.
Hi, we already add NFC in our application. You can test on Beautiful Widget and Plume, but we have to add the intent action, NFC discovered. Is there a way to share a normal action view intent?
So for NDEF there isn't, because NDEF is a very specific payload format. So this just works for the new Bluetooth APIs.
Where's your...
So, yeah.
We have rules.
Should we move the Q&A somewhere else?
Yeah, keep going with the Q&A, and if you kind of go this way to do pins, because we want to do Q&A, because this is important, and we can do pins outside, so please keep the questions going, and try and stay quiet down the front so the Q&A guys get there.
Sure, my question's about Beam and compatibility with non-Android devices.
Yeah.
Is that possible? Are those just NDEF messages, standard NDEF messages coming across to establish the Beam connection?
That's a good question. So we implemented all of the NFC forum standards for each of these things. So NDEF is one of these standards, but also for doing the actual data transfer, there's a protocol called SNAP, which is Simple NDEF Exchange Protocol, which allows you to send across NDEF messages. And this is a standardized protocol as well. So all of the devices that implement this protocol, it's an open protocol, will be able to receive beams. And in fact, we've seen Beam already interoperate well with, for example, RIM devices. The same goes for the Bluetooth pairing. There is a standard for that by NFC forum as well. So for example, passing on the MAC address. So everybody who implements a standard should be able to get this Bluetooth connection going and send data across. So it's all based on standards.
So a follow-up question to that is, you talk about sort of like the seamless experience of doing a beam between two devices, and it's my feeling that sort of tapping the screen is really an extra piece of friction that's not necessary, being that you wouldn't necessarily put two devices that close proximity to each other if you didn't intend to exchange, data. And I'm just wondering if that's something that could be removed or is being considered to be configurable at least.
Yeah, I think the short range saves us a bit there. If you play with a Nexus 7 and a different phone, you'll find that you actually need to be a bit careful with the positioning to make beam work. So in most cases, if you put something on top, you actually won't see any beam. You just need to put it in the right spot. But we could think of more advanced stuff, like if we detect that there's an NFC connection, we could, for example, disable the touchscreen so it doesn't react anymore to any input events. So that's something that we may consider in that case. But that's not currently done.
one of your demos, you showed basically Beam or NFC muting one of your test devices. So you had a tag that muted the phone's notifications. I'm wondering if there's any security considerations going into that, like maybe somebody put a tag somewhere that mutes phones and you didn't really want that to happen. Is there going to be a API at some point that says, do you really want to do this?
I should point out that these tag actions only work if you have the application installed to deal with them. So that's already a bit. And for this specific application, I know they actually pop up a notification saying that they activated something. So you do have a clue that something is ongoing. So I think it's a careful trade-off, right? Maybe you don't want to ruin the magic by allowing people to confirm. So I think in most use cases, the trade-off is right. You'll see something is going on, and if it's wrong, I think you'll catch a hint of it.
How's the Q&A going, Martijn? I'm a bit tied up here.
Pretty good.
Cool.
Lots of queuing here.
So, guys, I'm going to change tack slightly. I'm assuming I can trust all of you, right? Don't take a handful of pins. Just take one. And please, if you do take more than one, because you can't be trusted, you must beam someone else who hasn't got something, hasn't beamed, and give them one of the pins. How's that sound for a deal? Is that fair? So if you take two, make sure you give one to someone tonight. Spread the love, and let's do Q&A. So I'm going to put the pins here. It will be a free-for-all. Please don't crush each other. We value every one of our developers. We can't afford to lose you.
There's enough for everybody. So.
Hi, I've got a very related question. We're working on secure payments and was wondering if you have any security requirements for NFC specifically.
Sorry, could you repeat the question?
We're working on secure payments and was wondering if Google has any security requirements pertaining to NFC side.
So I think what we'd have you do is, depends on how you implement the payments. If you wanted to implement it over peer-to-peer, for example, the Android Beam protocol that we have, you need to do some encryption of yourself, because by default, the channel is not encrypted, right? So if it's your own application, I mean, Google doesn't set any requirements, but I think it would be wise to actually encrypt your traffic yourself and do some form of authentication to make sure that nobody can actually eavesdrop it. I mean, it's really hard because of the close range, but still I think it's a good idea to put some kind of encryption and authentication in these sensitive cases.
Okay.
Does that answer your question, or?
Yep.
Okay.
Hi, you showed in one of the demos where you were able to write multiple actions onto a passive tag. Does that work with passive tags from any manufacturer and of any type, or is there like a specific manufacturer that supports this? Or?
So the question was if the task launcher demo that I showed, it has multiple actions, if it works with all of the tags. So Android supports all of these standard NFC forum tag types, which is tag type 1 to 4 if you're familiar. So if you buy any of these tags, basically it should work with that. So they come in different sizes, but most of the popular tag types are just supported.
Okay, so you can write multiple actions to any of the standards supported?
Any of the standard tags will work, yep.
Hi. The Bluetooth pairing, the connection handover that you just showed, is it NFC forum standard based? Does it follow the NFC forum standard?
Yeah, so it's based on the NFC forum connection handover specification, which standardizes, the way the MAC address and the PIN is exchanged. Yep.
Okay.
We really hope that other platforms will pick up and do exactly the same thing, because that's just going to make it easy for users.
Okay, great. And when are you going to open card emulation to developers? Any point?
Yeah, it's a popular question still. We just haven't found the right way to expose card emulation and APIs to our users. I think when we do, we want to have like a consistent set of APIs and experiences. So one of the issues with card emulation is that not even all devices have a secure element, which I think makes it harder. And also, it has a limited amount of storage. So that means, for example, if your storage is full and you want to do some exchange, you actually need to remove something, stuff something new in there, and it basically destroys the entire interaction. So I think for the current use cases that we have, Android Beam is actually a really promising direction. And card emulation I see more as something to interact with the legacy reader infrastructure that we have in place, right? That's really what it's good for. Okay. But right now, because of the experience you have with card emulation is very fragmented, it's hard to get it to work. We don't want to offer any APIs because that would just get users frustrated that it doesn't work sometimes it does. It's hard to get it right.
Okay, all right, thank you.
Yep.
Hi. We work for a ticketing company, and integrating the NFC check-in is really something we are interested in. The thing is, the beam checking and this star field effect is kind of something that is slowing down the check-in. So are you guys considering giving us the ability to just get rid of it, or I mean, what are the plans on that?
Yep, good question. It's definitely something we're looking into. So the question was if we can speed up the Beam process for ticketing, where you really just want to tap something and walk on without having to tap anything. Yeah, we'll definitely look into this for the next release. As far as I'm concerned, it's part of the two-way communication protocol and customizing Beam. So there may be a use case where actually you just tap and immediately the data link is established and your application can deal with it. So we know it's an important use case, and we'll definitely look into future APIs to do just that.
Awesome.
Yep.
Thanks.
Again, sort of a security question. The 5 centimeters, is that reliable, or are there ways, with a Pringles can to get around that, read it more remotely?
It's really hard to get around it. I guess if you have a really sensitive directional antenna, you would be able to aim it right at it, then it could be possible. But I think it's, in practice, really hard. And also, most of the use cases, you just have your phone in your pocket, right? So at that point, NFC is not enabled, so it's really hard to get the data from it. So I think in practice, you could get a larger range if you have really expensive equipment, but it's not something to worry about in general.
Okay. And then sort of second question. Bluetooth low energy, do Android phones also support that? And maybe the Nordic, I think it's 2.4 gigahertz protocol that's used by Fitbit?
Yeah, I'm not sure what our plans are for low energy. I think it's different compared to NFC in the sense that Bluetooth low energy still has a large range, so you still pick up multiple devices, so you still have to select the device that you want to interact with, right? And the great thing about NFC is you can tap something to determine that you want to interact with it. So I think that's the main difference between Bluetooth LE and NFC at this point.
But all of those radio technologies can combine together to do really interesting stuff, and I think that's one of the great things about having an open platform is you can weave use cases and create new things that no one's ever thought of by using those things together. So, we don't see one of those technologies prevalent over the others. We want them all available to you guys with great APIs so that you can make magic.
So will Chromebook support NFC?
I don't think they do.
I don't think Chromebooks do support. I don't think there are any that have been announced to date that support NFC. But it's great to put a tag on your laptop, and then you can do all sorts of things. You can use that. So it's a good use for a tag.
Yep.
Hi.
Hi. For devices to support Bluetooth pairing via NFC, do Bluetooth device driver need to be updated?
So what we depend on basically is the existing protocol stack in Android, the OPP protocol stack for Bluetooth, because it uses the OPP protocol. I think actually most OEMs take the stack as is from Android. I don't think they have like a custom OPP stack in there. But the OEM vendors that do replace the NFC stack, they will actually need to write some code that allows them to do this. The main thing is basically about bypassing the UI. Because normally when you do Bluetooth OPP file transfer, you get a lot of confirmations, a lot of changes that you need to make. A lot of confirmations you need to do. So the main thing really that we change in OPP is that to determine if the transfer came from NFC and if it was NFC initiated, don't do all of this confirmation, but just make the magic happen.
Right.
So those are in.
We're actually out of time, so we'll take the rest of the questions up here. So we'll take them offline. Thanks very much.
We'll also be in office hours, by the way.
So
we'll be in office hours.
We will be in office hours, yeah, and in bars all over San Francisco.
Yep.
But yeah, thanks for coming to the Up Close and Personal with Android NFC, and go make magic with Android Beam. Thanks, guys.
Thank you.
Stick around.